I, I so wish I could speak Spanish because I'm excited about this topic, and even people who always speak English can never understand engineers. So I will try to speak somewhat slowly, but I have a lot to cover, so please listen as quickly as you can. Education is obviously really important. The economic malaise that is around the world will not be cured by anything other than education. Productivity is really important. But people are just waiting. This is a Chinese proverb. If you wait for the roast duck to fly into your mouth, you have to wait a very long time. I don't want to wait. I have a plan. So I want to talk about my feeling about education, and I believe that what I'd like to see happen in education applies even more directly for women than for everyone in general. So I want to improve education. I want to reduce cost. I want to raise the bar, level the playing field, and save the planet. And I am serious. It is very clear that young people now must practice informed, creative thinking, all three, all the time. Now, I believe that in order to help them do that, we must stop lecturing, outsource training, and start mentoring. So I'm talking about a major change in the way education is done. Let's talk about the stop lecturing thing first. Informed, I believe, is about being trained. The creative and the thinking part have to do with being educated. The informed piece has muscled its way into the space and taken away time to do the creative and thinking part. We must rebalance so that we have time to do all three. This implies that I think we can be twice as effective in training as we are now. I think we can do that. Now let me clarify a bit. Learning calculus is training. Learning to think using calculus requires education. Learning spelling and grammar is clearly training. Learning to communicate requires education. Learning a computer-aided design program is clearly training, but learning to design is much more sophisticated and requires education. And in general, learning the pieces, learning the parts of the whole is about training, but learning how to wisely and creatively integrate, bring together, requires education. I believe that training and education are quite different, that training is a commodity. It is not a high value added part of what happened. It's the education piece that provides comparative advantage. When you young people go out into your career, if you're just trained, that will not be enough. You must as well be educated. And I think too much of what we call education is actually training and quite poorly done. So I'm part of the problem. If I went to a Bad Teachers Anonymous meeting, I'd have to stand up and say, my name is Woodie Flowers and I'm a bad teacher. Because I've been there and I've been part of the system for a long time. This little video clip from a BBC program breaks my heart.
The engineering graduates of MIT have been right through the system of public assessment. But what real understanding do the creme de la creme have of basic principles if they can't work out how to light a bulb with a battery?
Do you have any idea why it's not working?
Battery could be dead, the bulb could be bad, I'm hooking it up totally incorrectly. I'm not an electrical engineer, I'm a mechanical engineer.
So obviously, we had failed her. That was slightly different. So she didn't recognize the part of the puzzle that was slightly different. So let's talk a little bit about training. We talk about whether or not we're even focused on the right stuff. My colleague Warren Searing supervised a thesis by Kirsten Wolf. She did a great thesis. She studied engineers who were about 10 years out with a survey. The survey got huge response. 46%, solid as a rock, good data. Here's one way to summarize the data. Engineers 10 years out from MIT said, you know, there's not a real good match between what we use a lot and what we learned while we were students. In fact, the things that we spent a lot of time on, we don't use very much. And the things that we really do all the time, didn't cover them that much. So there's a legitimate question about whether or not the right stuff is covered, and there's even a more profound question about whether the stuff that was covered was learned. Dr. Benjamin Linder, former student who's now faculty at Olin College, was doing a thesis with me on estimation. Estimation is a very important thing. He noticed that students had trouble estimating because they didn't seem to know the units of the things they were trying to estimate. So he designed a quiz that was very carefully done and gave it to 115 of our seniors. The question was simply, what are the units of these things that we have, quote, taught you? The results is amazing. Green is, I got it right. Yellow is, don't know, and red is wrong. That diagonal line means that our seniors knew the units of half the things that we had, quote, taught them. That's not a very clear endorsement of how much they were learning. Now, there's also some very substantial questions about whether the conventional process that we're using creates understanding. Dr. Crispin Miller did a doctoral thesis on that topic, and here's just one of many experiments that he did. He asked students, given a motor and a collection of pulleys, which pulley would you put on the motor shaft in order to create a lot of tension, a big force? Half the students got it wrong. They got it backwards. They knew there was some relationship between torque and force, but it was all kind of a muddle. They had no visceral understanding, no gut feel for what the answer to that question is. I believe very strongly that equations explain only to people who already understand. If you already understand, they're beautiful. But they don't tell you how to understand the phenomena. Because we write things on the blackboard and we think that people think like that. That's not the way we think. We think in color and sound and very textured stuff. We need to get over that and connect to real things rather than abstractions on the blackboard. There's a question about how much you really learn from analog mathematics. Linear algebra is probably just as important. Finite difference models, very important stuff. Statistics. We don't cover statistics in the United States very well at all. Geometry. We've lost geometry. Biology has gone back to geometry. And visual calculus is probably more, it's the one that I use all the time. So now let me talk about how to outsource training to something else. About 12 years ago, I wrote a chapter in a book. You can get a free download, a PDF of it, if you Google my name, spelled with an IE, and new media text, new media impact. It is an argument that is finally happening. I was way ahead of myself. I believe that textbooks are essentially where 45 RPM records are, and very few of you in this audience have ever seen a 45 RPM record, implying that I think textbooks are still back in the last century. Everybody says just be patient. I do not think we have the option of being patient. There's some progress being made. If you do not know about the Khan Academy, you should check it out. This is the way it is produced. K-A-H-N Academy on Google. There are 3,000 little short videos. The point that Sal Khan is making is that if you do the homework in class and do the lecture at home, it makes more sense. I believe that he's saying the same thing I'm saying about training and education. You want to do the homework with the expert, the teacher, so that you become educated about how to think about the problem. You can listen to the lecture anytime as you're going to sleep, etc. So that's one thing that's happening. Recently, biology illustrators have done fantastic jobs of animating microbiology. The person who did this Inner Life of a Cell, it's available on the web, done in collaboration with Harvard biologists. Beautiful illustrations of the phenomena that are in our bodies. It's really fascinating to see some of the things that are happening inside our cells now. And E.O. Wilson hired that illustrator, that animator, to help him with the new book, the e-book, called Life on Earth. The first 2 chapters are available for free download from an iPad. How many of you have seen that chapter? Only a few. So get a chance to see it. I believe it is the precursor of things to come. It's not yet, however, connected. So in the connected space, so that you have feedback, MOOCs are happening very quickly. MOOCs meaning massive, open, online courses. Stanford started last year with a course that had 140,000 students. This one you see is being automatically graded. Feedback is happening all the time. MIT has just announced MIT-X, which will be a MOOC source. Harvard is now in an alliance with MIT with Harvard-X, and the two together are the supporters of something called edX. I believe that's a major step forward, in particular if the quality of the presentation is elevated quite a lot. So all of you will be able to take courses in many things for little or no money. And I believe the courses is more training than education. But if they're well designed and there are forums and social groups connected to them, I think they can become a source of education as well. So there's an explosion in this training space that's going to make it much less expensive and more efficient to train yourself. New media texts are getting good very quickly, stepping up in production value, but we're nowhere near this stuff. The people that do video games are extremely sophisticated. We need that sophistication in training aids for education. The people that do Angry Birds have got my wife and I's number. They have hooked us bad. But the real elephant in the room is Hollywood.
I became a Marine for the hardship. I told myself I can pass any test a man can pass. All I ever wanted was a single thing worth fighting for.
Ladies and gentlemen, you are not in Kansas anymore. You are on Pandora.
You should see your faces.
We have an indigenous population called the Na'vi.
Have you ever seen anything in education with that kind of production value? This is the credits to the movie Avatar, speeded up by a factor of 8 or 16. I can't remember what I did. 1,000 people working 4 years to do the movie. Red special cameras, all leading edge technology. Everyone on that list is either the best in the world or one of the best in the world at what they do. So why do we do that? Why do we spend almost nothing on textbooks, one author, writing away peacefully? And the whole entertainment industry does these really big, extremely well-produced, super professional things. When if you look at the impact, if people learned what was in the textbook, it could have a big impact, where the movie long-term is going to be another speck in history. So we got it all backwards. If you look at calculus in the United States, for example, 600,000 college freshmen take calculus, which is remedial calculus, each year. Does that number make you want to faint? That's horrible. No productive system would tolerate 42% failure rate. We need to fix that. If you make the assumption that each of those failed courses is worth $2,000 for, in the United States, that's a very conservative estimate. That's the budget to make the movie Avatar every year as a recurring cost for one course at one level. I have absolutely no doubt that we could cut that failure rate for calculus in half. I think we'd actually do better than that. So I don't understand why we're confused. We need a system. We need a backbone. We need a system that forms the core, onto which all the things like Twitter and Facebook could be connected, and people could make apps that go in, and the content of that should be very high quality, highly produced stuff. If I were deciding that I wanted to study differential equations, I'd pull down the menu and pick the course. And since I know I wanted to study mechanical engineering, I'd want all the examples to be in the context of mechanical engineering, and they would all be there because the system would give them to me in that format. And let's just say that I wanted to do this old-fashioned thing, just to try it, and learn from lecture. But I know that I don't really like differential equations, and I've taken this test that says I'm ADHD, so I want the system to poke me and say, are you paying attention? Every 10 minutes. Give me a little quiz, so that as I go through it, I'll be constantly being updated. And I also know that I need a good, powerful Spanish voice for this lecture. So I want the voice to come from someone who has both seriousness and humor. And I also want to be compelled to watch, and I think because she has an absolutely beautiful abdomen, I think that the visual avatar should be Lady Gaga. Now, we know how to do this. I'm not saying this is what we should do, but we should do at least something innovative that captures people's attention and is well done. I believe it's going to happen. If we had this thing that had closed loop, it would get better all the time. It would be a great research platform. If you had only 2 million users, which is a small number, Sal Khan's Khan Academy now has about 5 million users. But we would get more data on the efficacy of various techniques in education per week than we currently get per decade. If you had animation, it would be interactive, continuous updates. The textbook would get better every day. Automatic homework grading, automatic quiz grading. You could compare one school to another. All kinds of things could happen. We would learn a lot about the efficacy of various learning styles, about how you scaffold what you know so that you understand. We'd learn what's retained. You know, we don't know the shape of this curve. Right now, you take a quiz that you crammed for the night before. That doesn't mean you're still going to know that stuff in a week or a month, etc. We could learn a lot from a good, well-developed system. So for the first time in human history, we would have compound growth on the quality or the efficacy of the things that we currently call textbook. Things could get better fast. I believe the change in slope could be more important than Gutenberg inventing the printing press. So we're at a tipping point, I think. It's happening quickly. A lot of core codified materials can be done this way. I met with a venture capitalist a couple of weeks ago, and he said in the United States, in the last year, between 500 and 1,000 new companies had been started in this space. So stuff is going to happen. You are going to be able to not carry around textbooks. You're going to be able to learn in much more different ways. And if you can do it that way while you're in class with a teacher who is an expert or working with a mentor, you can understand the phenomenon before you are hit with an abstraction of the phenomenon. Here's an example of a thing that Ben Linder did after he arrived at Olin College as a teacher. Click beetles are these funny little beetles. You put them on their back, they bend a little bit and then snap. So they're essentially a spring that gets cocked and then released. Ben said to the students, learn about the click beetle, then go to the server and download this software package and train yourself to use it. I'm not going to teach you to use it. Go learn how to use it yourself, and then use it as a tool in designing your things that mimic click beetles. So they were spring-loaded plastic laser-cut widgets that stuck to the tabletop and jumped. And typical Ben Linder course, it was delightful, and the kids learned a whole bunch, and they had a lot of fun. But I think amazing things happen. You know, Mel used the simulation package to learn about the length of the tail of her flipper and see what that did to the dynamics. David Wirtz did something that's stunning to those of you who know engineering and simulation. His video, and I mean his actual device and the simulation were so similar. I mean, that's essentially identical. Not long ago, a very experienced modeler that spent years programming a computer couldn't get this close. And now someone can go learn how to do this by themselves. So I argue that these freshmen had not yet had mechanics, but they're in a much better position to understand mechanics when they see it in the abstract form. They will have some way to scaffold that. So use scaffolding, build abstractions on observation and experiences. And I believe since women have been culturally deprived of the opportunity to get their hands cut in shops and learn things by bumping into stuff, it's more important for women, I believe, than for men. At MIT, there's a lot of history. My whole teaching career has had to do with learning, working with students as opposed to talking at them. It's pedagogically completely different when you say, I don't know, let's find out. Or, gee, that's an interesting question. Who might know the answer? If the teacher is thought to have the answer and the students are trying to find it, the psychology is all wrong, I think. If you are working together to try to find an answer that neither of you know, I think things are very different. So, based on a bunch of essays that I collected from students in the first robotics competition in the United States, and quite a number of years of experience myself, all girls' schools provide an opportunity for them to build confidence in their ability to do things they didn't think they could do, so they're better in a position to get into a coeducational group in the workplace and elbow their way into the machine or whatever they need to do and get the testosterone-poisoned men out of the way. So starting that, I think, should happen as soon as possible. Doing individual design and build things, if you're not already. One very simple one is if you take a brick or something heavy like that, and you pass it around and have everybody feel the brick, and then you put the brick away and say, okay, here's a stack of index cards. Your challenge is to build a tower that's a little less than 2 cards tall that will support the brick. Well, that's easy. I can just stack up that many cards, and you know that'll work. But that's not any fun. You want to make it interesting. So you say that each card costs €1, and each staple that you use costs €1, and each fold costs €1. And the only rule that you have to have is that a continuous fold is an infinite cost. So you have to, if you want to make a tube, you have to make discrete folds, okay? And then you line up the towers, most expensive to the least expensive, and let the students put the brick on the tower, and you get down near the end, and it gets to be really exciting. And there's a million ways to solve that problem, and you can actually teach quite a lot about stress concentration, for example, because the perfect tower is the one where every part of every card is just about to fail. And that's what you're trying to do. Another one that you can do that's interesting is if you build a ramp. And you put a block, barrier at the ramp and a little car on it, and you put a passenger in the car. And what you're trying to do is make sure that when the car goes down the ramp and runs into the barrier, that the passenger doesn't fall forward and be killed. Now, do this with the same constraint, the same €1 per fold card staple, and the cheapest barrier is the one that wins. How you do this experiment dramatically changes depending upon how much experimentation you do. Because if you can just try something and roll the cart down, try another thing, if you do that, you're not thinking. But if you set it up where you say you get 2 chances to try experiments, then you have to think, you have to model. You have to be careful about what you're doing. So there are lots of ways that can be set up very simply. Now let me go to the other end of the spectrum of design, build, entrepreneurship involved, etc. At MIT, the senior design course is currently being taught by Dave Wallace, whose face you just saw. Dave is a former student. He's an absolutely wonderful guy. He's really smart, has degrees in both industrial design and mechanical engineering. So in that course, the students get a job too big in a time too short, with a team too large and a budget too small. And it's a lot like life, right? And what they do is they go from concepts to products, alpha models of products, in 14 weeks with a group of 20 people and a budget of about 5,000 euro. That's hard. It's a big group. You can't let 2 or 3 students do it. You have to use some management techniques. Now, if you go to the MIT website, which is easy to find, and put 2.009 in the search window, you can find a huge amount of information about this course and its history. Dave has done a fabulous job of documenting everything that happens. You can look at videos of presentations. You can look at the lectures on modeling techniques, on how to build bench-level prototypes. Huge amount of information available. If you want to kind of get a feel for what the course is like, the current edition of Technology Review magazine, here again, it's easy to find on the web, and put into the search window Wallace and 2.009, and you'll find the longest article Technology Review has ever published about that course. One of the reporters spent the entire semester. And one of the things that's nice about it is, for example, each team includes a librarian. Each team includes product designers from local industry. The teams are very multidimensional, and they do really neat stuff. Here's a picture of the article that you'll find in Technology Review in Dave Wallace in Dave Wallace style. There's several videos in that article. And one of the things is team building exercises. There are lots of variations on them. In this particular exercise, the team members are given an envelope, and they're told you're going to build a balloon tower. The tallest tower wins. But the team members are given an envelope that has their behavior characteristics in it. You're an obnoxious, pushy team member. You're a stand back and not get involved team member. You are the one who argues with everything that's said. So when you do that exercise in that context, you learn a lot about what happens in real teams. And you see how difficult a person can be as a member of a team. So the students spend a lot of time with each other in the shop. They spend a lot of time building and testing, making sure that they know what they're doing. They spend a lot of time researching product ideas. Spend time with the staff in the shops and with the faculty. And the finale presentation is a big deal. The 2009 presentation is now the biggest event on MIT's campus in a year. It's bigger than any football game, bigger than any sporting event. The auditorium, the largest auditorium this last fall, had to turn away about 400 people that couldn't get in. Last year they had a rock singer who had a very good band backing her, and she'd written several songs to go along with the production. So this is just presenting design projects, right? But as theater, a real celebration for having done something that was really impressive. This last year the theme was food. Many different things were built. This is an egg washer for a small farm. It's still being used in a farm that's sponsored by Tufts University outside Boston. This was a shopping cart for an adaptive device for a wheelchair. Have you ever watched a person in a wheelchair try to push a shopping cart? It's really very difficult. This is a very clever solution to that problem. This was a wood-fired milk dehydrator for use in Africa, where the dairies are quite often so far away from potential customers, people that might drink the milk, that with no refrigeration system they can't get it there. But if you had a wood-fired system to dehydrate milk, you could then transport it. clever idea. The point I want to make about that course is that I have been associated with it for a long time, and Dave has been doing it for 10 or 15 years now. Women are better team leaders than men by an order of magnitude. You women just absolutely trounce us at that process. I think that's really, really important. Quite often, the guys want to police your own trademark. I'm doing this. Leave me alone. The women are much more likely to see the team as something that must function and pay attention to all of the emotions and things that are going on. They are also absolutely equal in shop technique, in analytical technique, all the other things, but they bring to the situation a kind of sensitivity that we men badly need. So that brings a little comment on ethics. I'm going to flash through this description of a project, but we've done. If you encounter your first ethical quandary as a professional, it'll be really hard. If you've not thought about ethical complexity and thought about how you deal with it before you get into a job, or in graduate school is full of potential ethical holes. Like your supervisor wants to put his name on your research work. What do you do about that? So we've gone through several layers of ethics projects, and my comment is that you must deal with it while you're still a student and get accustomed to how you address an ethical quandary. I wrote the foreword to a book on engineering ethics by Dr. Caroline Whitbeck. I think it's a very good book because it argues that ethical situations are like design problems. You have to use the same kind of process to sort out what you should do. The answer is not call a press conference and blow the whistle on the jerks. It's to think carefully about what you know to be true and to seek the least painful solution and to document what you're doing and seek expertise. So students at MIT had, when they write their own canons of ethics, do a pretty solid job of respecting one another's professionalism. They do a pretty good job of thinking about the end user. They do less well when it has to do with, are you responsible for taking care of one of your colleagues that got drunk and is misbehaving? And they don't do a very consistent job when it comes to things like digital music. In the group, each person respects the other person's intellectual property. But when it comes to the intellectual property of a musician, well, maybe not. Now, I don't believe these are bad students or bad people. They're great people. They're really smart. But they haven't had the time to think about how to deal with those kind of complex issues and to try to create a set of ethical behaviors that's consistent. Simon Baron-Cohen's book, The Essential Difference, when it came out in a hard copy years ago, it had a title, The Truth About the Difference in the Male and Female Brain. I recommended it to several women friends. They almost threw it back at me because some of them didn't like it. But I think he's done some really important research work. And one of the things that I took away from the book was he'd done a lot of research on characterizing men and women with regard to their ability to be empathetic or systematic. And obviously, all of us in this room are at that star up there, right? We're all super empathizers and systemizers. But in fact, on average, men test 70-30 toward systemizing, and women test 70-30 toward empathizing. And I believe that is the reason that we need more women in technology. Not because it's fair or anything like that. It's because women bring something that's very badly needed. My personal opinion is that empathy-based ethics is probably the most robust that you can find. If your ethical standards are somebody else's list, I think you're in trouble. Because in particular, the young people here, you're going to encounter things that are not on anybody's list yet. So you have to have some way to deal with that. I believe empathy-based ethics is a very good way to do it. I also believe that good products involve being empathetic with the potential user. If you can think about the user and be kind to them, you make a good product. I'm staying in a wonderful hotel. The person who designed the shower control hated me. It's a terrible, terrible design. All the time I encounter things like that, and I just know they weren't thinking about the user. So, women are needed. Learn enough about nature to be in the game. Humanism is important, but nature is a bigger deal. So you got to not only learn about people, learn about Mother Nature, and start businesses. We need many more businesses that are focused on some of the things that are really important. So I'm going to talk about first, and I want to gauge. So I will end at 45 minutes. First, as you heard, stands for Inspiration and Recognition of Science and Technology. Many years ago, when my hair was a little bit longer and maybe a different color, I started doing design and build things at MIT. That was the way we did it back then, guys. That was near Harvard Square in the 70s. It was the happening place in the world. Anyway, those competitions grew over time. They became very well known and have expanded. And the follow-on course, the number that has replaced that is now 2007. Their competition for this year was last week, and I took a few pictures. It was a carnival thing, and the robots, in this case, this robot's going over to hit the anvil to do the strength test and ring the bell, and you see the hammer coming over and bang, and it did it. It's festive. The competition is not determining grade. It's a celebration of what you've learned. Women do really well in 2007, and they're a major part of the whole operation. They bring the different stuff to the party. It is easy to imagine that MIT students who are very competitive would accept the challenge of taking a box of materials and out of that box of materials build a robot to accomplish a particular thing. Nobody's surprised. What's, I think, more interesting is that when I started saying, but compete like crazy, but treat each other nicely in the process, and experience the satisfaction of teaching your buddies everything that you learn. And that was back in a time when in law schools, students were tearing pages out of the reference books so others couldn't learn the cases. It was delightful to see that the students, engineering students at MIT, exhibited this wonderful behavior of competing like crazy, but treating each other really nicely. And I started calling that gracious professionalism. And gracious professionalism is one of the cornerstones of FIRST. I met Dean Kamen in about 1990, and he had founded the organization FIRST and was looking for something to do. And I had been hosting a television show that featured documentaries on 270. So I showed him the video, and he said, let's do it. So we started doing that and founded the first robotics competition. Maze Craze was the first one. Little robots running around in a tray of corn. Now there's Junior First Lego League, which you guys know very well here. First Tech Challenge, which is revving up in Spain. And the first robotics competition is the big robot. The numbers are big and impressive. A lot of stuff happening. 15 million in scholarships is a nice thing to go along with FIRST. I was at the European Open last year at Delft. That middle picture on the top may look familiar to some of you. It's an outstanding Barcelona team from Laval. Wonderful, diverse stuff. So the Junior First Lego League kids learn about research, do really interesting things. This was the beginning of the first Lego League competition in St. Louis last month. People were just beginning to arrive, but you can get some size for the idea of the scale. The robots at First Lego League are really great. It is a wonderfully diverse international group. Many people doing things they hadn't done, but it's serious competition. Notice the facial expression not only on the kid, but on the referee. Focused. Good way to learn. First Tech Challenge is one step up in robot complexity and size. Metal robots, more power, things like that. The FRC robots, the big ones, are faster than me and don't weigh almost as much as me. When there's 6 of them on the field, it's quite amazing to watch. Last year, by the way, the big robot could deploy a little robot that could climb a pole. So the one that got to the top of the pole first won big points. So it's really fun to see the big robots turn loose of their baby robot and back off and watch that happen. So here's a video clip of one of the finals matches in the regional event in Chicago in this season of the first robotics competition.
We're counting down. 3, 2, 1, go!
All right, here we go. It's the finals, baby. Couple of quick scores by the Red Alliance. Now a couple of quick ones by Blue. 2 seconds, one.
They're in autonomous at first.
2-point advantage.
Now the drivers have taken control.
Drivers have control of the robots. Wild Thing pulling those balls from the blue bridge over on the blue side of the field. Robo Wranglers doing the same for red. And there's the Bomb Squad putting one up for red, and Robo Wranglers putting one up as well. 3 points and 2 points. 3 points and 2 points. Red Alliance with a 31-18 lead. There's a miss over for the blue, but it rims into the 2-point.
Notice they're fast.
There's a 3-pointer.
Several kilowatts power.
8-point advantage, red.
Cameras on board with illumination systems. Cameras that can see the outline of the goal.
Wild Sting with a couple
The robots
of
are putting backspin on the ball so that it hits the backboard and goes in quickly.
Well over 1 minute 66 seconds still remain in this match. We've got a red robot playing defense.
Notice how close the score is.
We got the Bomb Squad over on the blue side grabbing some balls. Beatty putting one up over the backboard. Wild Sting trying to score, that one falls off, and then they get one in. It's all tied up at 38, folks. We got 46 seconds remaining in this match. This is for the championship, folks. First match.
So at the championship, there were 500 of those robots.
42-38 now in favor of red. Coming down to half a minute. Wild Sting misses for blue. Then they put
at the end, they get big points for balancing on those teeter-totters that are out in the middle of the field.
So red maintains a 2-point lead. 20 seconds remaining in the match. Human player for blue puts one in for 3 points. 2 robots up on the red bridge. It's filmed.
The guys that built that robot just hated rotating arm shooters. They wanted to make a catapult, and they made it work. Notice on the other side, oops.
4, 3, 2, 1.
So the balancing robots on this side won enough points that they won that round. Okay. So it's not about fancy robots. It's about what happens when young people work with mentors, work with experts. It's about gracious professionalism. If you go to Google and you put in the term gracious professionalism, you get a whole bunch of hits. The Urban Dictionary has a definition that includes an example. It says, giving a needed part, essentially, to your opponent so they don't have to forfeit is a good example of gracious professionalism. I love that example because it happened in the finale match 2 seasons ago in Atlanta. So the big prize, however, is not for the most effective robot or most effective driver team. It's the chairman's award in first robotics competition, essentially the most exemplary relationship with community. And these tears of joy are being shed because these kids just won the chairman's award, the national chairman's or the world chairman's award. This team is from the toughest area in Phoenix, Arizona, dominated by gangs, mostly illegal aliens. Most people didn't want to go to finish high school, much less go to college. Almost the entire team went to college. The mentor has been unbelievably effective as a high school teacher. The woman that you see crying there, here she is a couple of weeks ago. Time magazine named her one of the 100 most influential people on the planet because of the work that she'd done on the effort to get the laws changed so that she, for example, could stay in the United States. Some of her teammates were able to take advantage of changes because of her work. So, FIRST can do some of that other stuff. Now, whether FIRST is about inspiration or education, Dean and I have this running battle about it. We both know that we're both right. It's both. Last year's freshman class at MIT, 10% FIRST alumni. That's a really big deal. That's a big ratio. Being involved in FIRST, doing hands-on stuff, doing stuff that involves teamwork, society, electromechanics, computers, very important way to get into a very good school. So, the championship is a big event. Last year, will.i.am and the Black Eyed Peas gave a big concert. will.i.am was back this year, helping with FTC, and I'm going to skip these two videos. This video I'll only tell you a little bit about. I included it because it's produced by a team that was specifically focused on communication. Ed Barker, the mentor for the team, was struggling to get more women involved in the robotics team, so he decided we'll get good at communication. So the team now has been to the White House. They've testified before Congress. They've won several national environmental prizes, and they've done just an amazing job of producing video and communication. They're really, really good. Giving back. So balance, folks. The old definition of a liberal education was way too off-center toward humans. The universe is a really big thing. So learn about nature in addition to learning about humanism. And I believe that we're going to start redefining the liberal education, one for the 21st century. Because if you're going to be in the game and attain some satisfaction and have a better shot at a meaningful life, it's going to be because that you've done informed creative thinking, all three, all the time. Thank you.